This is the ME475 final project by Colton, Knopf and Raden. Here's a picture of the bike frame we were assigned. We brought this into NX11 and created a point field. Using that, we brought that into ANSYS to start our analysis. The initial frame design started with using a chromoly steel 4130, which has an ultimate yield strength of 435 MPa and an ultimate tensile strength of 650. Poisson ratio is 0.29 and the modulus of elasticity is 205 gigapascals. Initial wall thicknesses were based on the provided paper and thickened after doing an initial run on each loading scenario and maintaining a fork and frame below the maximum allowed mass. The frame mass is 4.98 pounds with a fork mass of 1.99 pounds. The first loading scenario we used was the road bump front wheel that we found in that paper. Remote displacements were placed on the rear axle, seat post, head tube, and front axle to prevent rotation, and a force of 2,600 newtons was applied in plane with the fork. For the road bump rear wheel, we used a remote displacement on rear axle, seat post, head tube, and front axle to prevent rotation again, along with a force of 2,600 newtons parallel with the fork applied to the rear axle. Next, we had a load case that was climbing on the saddle and climbing off the saddle, two load cases that were included in that paper. We decided to use a 500 Newton force on the seat post, 70 newtons where each hand would be, and then a 1,600 newtons into the pedal face, and both axles and the seat tube were fixed. For the climbing off the saddle, similar forces were used, except for the seat post force. The next two loading scenarios we created ourselves. The first was a drop case to represent coming off of a curb. Both axles were fixed and downward forces were placed on both the pedals and the handlebar. The next was our curb impact case, which was to represent the worst case scenario the bike frame would experience. This was meant to represent someone coasting on the bike into a curb. Both rear axle and the bottom bracket were fixed with a force applied at the front axle, in plane with the ground. This load case was to use to determine if the fork or head tube would break. Next, for our aluminum frame design, we decided to use ANSYS aluminum alloy. This has a yield strength of 280 MPa and ultimate tensile strength of 310. It has a Poisson's ratio of 0.33 and a 71 gigapascal modulus of elasticity. The same iterative process was used to design the frame cross sections as steel. All wall thicknesses increased on the steer tube, fork, seat post, and top tube, and the outer diameter was increased as well. The final frame mass came out as 2.7 pounds with a fork weight of 1.28.
The results of the 6 loading scenarios for steel are shown here with the curb scenario showing largest deformation and combined stress. The results of the 6 loading scenarios for aluminum are shown here with the highest deformation and stress at the same scenario as steel. The front wheel road bump total deformation is shown here with the aluminum frame deforming 0.2 millimeters more than the steel. The bending stress for the same scenario with each frame is shown here. A buckling analysis was performed for the rear wheel road bump and the curb impact loading scenario, both on the steel frame. A modal analysis was performed on the steel frame for the curb impact scenario. 3D analysis of the frame was performed for both steel and aluminum with displacements inputted to recreate the deformations seen in the curb impact for each frame.